Hey, glad you decided to join me for one of my last videos for the year 2020. A little bit of a math review of what you guys were doing on Tuesday. Yesterday, you just had a nice little snow day. If it was up to me, you guys would be doing math, but uh, I'm the math Grinch, maybe. But anyhow, got a couple problems that I asked you to try in the last video, and let's see if you got the right answers for them. All right, so you want to get x squared by itself when you're trying to solve these equations. These are quadratic equations that don't have a middle term bx. Before this, we were solving these equations by factoring, but a lot of times these ones here will not factor, so you can solve them by square roots. I already did the first two steps in undoing the equation, undid the 25 by subtracting, and now I'm undoing the multiplication by division. Okay, so at this point we would have x squared equals negative 25 over 4. All right, and to solve this equation, you would square root both sides. All right, now remember what I've been telling you guys. As soon as you square root both sides, you have to put a plus or minus sign in, because there's two possible answers to an x squared equation, all right, that you square root both sides on. Next, since there's a negative underneath the square root, remember that negative square root of -1 is equal to I. So what we're going to do is we're going to pull out an I, okay? That's that negative underneath the square root. We pull it out, it becomes an I. And I'm also going to take this fraction, and I notice that these are both perfect squares, so you can split it up into the square root of the top and the square root of the bottom. And so my answer is going to be x equals plus or minus I times, square root of 25 is just the number 5. Let me fix that there real quick. All right. And then on the bottom, the square root of 4 is just 2. All right, or you can write it like this, plus or minus 5/2 I, okay? Probably better to write it like that. Okay, on to the second try it problem here. And this is the one that I snuck into the video just to see if you were paying attention. So here you're simplifying this, or really you're finding this is multiplication, okay? So when you have to multiply these two, these are called complex numbers because you have a real part and an imaginary part. You just want to do FOIL first, okay? So you take the first, which is 5 times 4, so that's 20. The outside, so that's 5 times a negative 7i, so that would be a negative 35i. The inside is 3i times 4, which is 12i. And the last terms is 3i times a negative 7i. So that would be negative 21i squared. Okay? Now, I'm just doing this off the top of my head here, so I could have made a mistake. So just be careful. Let's see, make sure I did everything right, and it looks good. All right, so next we need to combine some terms. Combine these two middle I terms. So that would be negative 35 plus 12. That would be you'd subtract them because the signs are different, so that would give you 23, negative 23i. And here, remember, I squared is equivalent to -1. So anytime you have an I squared, you want to make that into a -1. So this part here would be negative 21 times a -1. Then you have two negatives, so that becomes a positive. Okay, most times I just skip that step and just make it plus 21 right away. Okay, so we want to write our answer in complex form. So we need to combine these last two constant terms. So we have 41 minus 23i. Okay, now when I say complex form, I just mean the form a plus or minus bi. Okay, so there you have it. Hopefully we simplified that all right. And on to the next one, which is a little bit harder. Okay, here you are dividing, okay, a complex number, and you want to write it in the form a plus bi. So you have to get rid of the imaginary number in the denominator. Okay, now remember there was something called the complex conjugate. Okay, so here, if you have a imaginary number in the denominator, you want to multiply the top and bottom by the complex conjugate, which is the same real part, but you switch the sign on the imaginary part. Okay, so 2 minus 6i, the complex conjugate would be 2 plus 6i. Okay, now when you're multiplying by this, you want to remember that the top should be in parentheses, okay, and the bottom is also in parentheses, okay, and there is also understood parentheses here, okay, and then there's a little shortcut when you multiply a number by its conjugate, okay, so the result of a number times its conjugate is a squared plus b squared, okay, and here a is equal to 2 and b is equal to 6 or negative 6, depending on which way you look at it. Okay, and it doesn't matter because if you square a negative 6, it's the same thing as if you square a positive 6. Okay, so on the top, I'm just going to distribute. 80 times 2 is 160. 80 times 6i is a big number. 80 times 6 is 480. 6 times 8 is 48, so you just add an extra 0 there. 480i. Okay, on the bottom, we're going to do the a squared plus b squared, so it would be 2 squared. Plus b squared is 6, or b is 6, so b squared would be 6 squared. Alright, and then once again, you know, I'm just showing you that step for you guys. You could actually skip that and go right to this part. So you have 2 squared plus 6 squared, so that'd be 36 plus 4, so that's just 40. Okay, and now you want to write it in the form a plus bi, so now you want to reduce 160 over 40, and reducing 480 over 40. Oops, 480 over 40. Okay, and see if you can do that mentally. 4 goes into 16 4 times. Alright, so that's just 4. Okay, those zeros would cancel out. Here, 480 divided by 40, those zeros cancel out. So this is just 4 plus 12i. Okay, so that's it for the try it problems. Now, there was one extra problem that we didn't get to. I'll do it for you guys real quick. It's very similar. So first, you want to get rid of the I in the bottom. And to do that, you need to use the conjugate, complex conjugate again. So it's going to be negative 1 minus 2i. This time is the complex conjugate. You're going to multiply the top and the bottom by that same thing. That's equivalent to multiplying by 1. Okay, so now, if we multiply the top, we're going to have to FOIL here. So let's see. First term would be negative 4. Outside term would be negative 8i. Inside would be plus 3i. Last term is negative 3i times negative 2i is 2 negatives make a positive, so that's positive 6i squared. All over on the bottom, it's going to be a squared plus b squared. So a is negative 1, we have negative 1 squared, and b is 2, so we would have 2 squared. Okay, that's the shortcut when you multiply by the conjugate that I was mentioning up here. Okay, so let's clean up the top a bit. Let's see. Combine like terms. So we have negative 4. Combine these middle two. That's minus 5i. 6i squared becomes minus 6 because it's I squared to negative 1 times 6 is negative 6. On the bottom you'd have 1 plus 4. It's 5. Okay. And now combine negative 6 and negative 4 makes negative 10. So you have negative 10 minus 5i all over 5. Then you just divide both of these by 5 and you'd be left with negative 2. And then negative 5i divided by 5 is negative 2i. Okay, so they're both negative because they were both negative above here. Alright, and so I didn't split it up like I did this one, but if that makes you feel better, you could split both parts on the numerator over the number on the denominator, then reduce it. But since they both divided evenly, I just went ahead and I divided them both. But I did make a mistake. Did you catch my mistake? If I take 5 and I divide by 5, it's not 2, it's 1. Okay, so we have negative 2 minus I. Alright, that's it. Okay, hope you enjoyed that. Work with complex imaginary numbers. And if I don't hear from you until next time, hope you guys have a Merry Christmas and a Happy New Year. Try to do those practice problems I'm going to put up too. And take care. God bless. And praying to see you guys in the New Year's. All right. Bye-bye.